15 minutes in total, including 5 minutes for presentation and 10 minutes for live video and so let's welcome our first presenter, Susanna. He will give us a talk about M3 Tricity, visualizing evolving software and data cities. So welcome, Susanna.
Thank you. It's good to be here. Can I start the presentation?
Yes.
Okay. Can you see the screen? Okay.
Yes, it's good.
Hello, I am Susanna Ardigo, and this is Metricity, Visualizing Evolving Software and Data Cities. This paper is co-authored by Csaba Nagy, Roberto Minelli, and Michele Lanza. During the lifetime of a system, many developers work on it, on different parts that interact with each other. Considerably more time reading and understanding the existing code rather than writing new code. This makes program comprehension a fundamental activity for software maintenance and evolution. A popular technique is software visualization. The city metaphor for visualizing systems in 3D has been widely explored, and it has led to many diverse implementations and approaches. For example, we have CodeCity, which visualizes the source code of a repository by mapping packages to districts and classes to buildings. Dahlia visualizes a database by mapping creation time to districts and tables to buildings. These two cities look very similar, but they are two parts very different in the system, which are software and database. Only few approaches consider presenting these two parts together. For example, Dahlia 2 visualizes the two cities side by side. These approaches focus on visualizing either the source code of a software system or the schema of a database. In addition, the repositories contains data stored in files, which is not shown in current approaches. We propose a novel visualization for software system, its data, its interactions in the same city. Our model resembles real systems. The packages contains files named classes for source code, data files for structured data, and binaries for generic informations, which are not very much always structured. A database contains a collection of data named tables, and we have a table access, which is an association that links tables with classes. This can represent statements such as creation, update, retrieval, and deletion. A database is usually not versioned within software repositories. We use SQL Inspect, a statistical analyzer that, given the source code of a repository, it finds the location of queries and infers the schema. Data in software are different, and the representation needs to show this. We have blue code buildings, cubats as code buildings. Data files are orange cylinders, and binaries are gray hemispheres. These entities are part of the repository, and in previous approaches, they were either rendered as code buildings or deleted during the analysis. Regarding databases, we created the table cylinder of red color. This entity type is inferred. For this, we gave them a ghosted look, making them slightly see-through. We present a novel way to add the database to the visualization. This is the new look of our city, but something is missing, the database. It is not physically present in the versioning system, thus it would be inconsistent to visualize it with the repository. We added it to the visualization in one space, remained left unused, the sky, creating city with clouds. The two components face each other and grow toward the other. The space between them allows for a direct mapping of the table accesses. Let's take a closer look. The shapes and colors of the meshes help to easily distinguish all the entities and understand their role in the system. This repository is filled with data files and binaries, which we will see later in the demo. The database contains few tables which are accessed by more than one class. As you can see, more lines are coming from each table. A second visualization places the database below the surface, creating the city with underground. The mapping is not as direct. In fact, the classes that access the tables have a see-through basement below the city, which is connected to the database. The implementation is divided into backend and frontend. The frontend is written in TypeScript, It uses Vue.js as a framework. The canvas is created using Babylon.js, an open source game engine. The front end contacts the backend through HTTP requests, and WebSockets are used to exchange information. The backend is written in Java and is built using Spring Boot. It uses MongoDB as a database for permanent storage. This tool is available online. I am Susanna Ordigo, and this is the presentation of Metricity, visualizing evolving software and data cities. If you're interested, stay for the demo. Thank you. Can I switch and start the demo?
Yes, I think you can go ahead with the demo.
Okay. This is the homepage of Metricity. The logo is in the center of the page, followed by two parts. The form is composed of a bar to insert the URL of an existing Git public repository, and the user can choose as append setting the database type and dialect used for the analysis. We have 4 as well as no database. The second part is a table of repositories. The columns show the name of the project, the owner, and database type. The top rows shows project ready to be visualized, while the bottom rows are project currently being analyzed that will be available in the future. You can see the one that we just inputted. And now let's choose one for the list to start visualizing the actual city, Money Wallet. There is a loading screen. This is the main page of Metricity, the city visualization. At the center, we see the software city with folders and files represented as building and nested districts. Above the city, the sky is used to visualize the inferred databases and their tables. The connecting line represents the table accesses found in the source code. The corners show information about the repository and the commit currently being displayed. On the top, there is repository-related information like the name and the owner of the project, while the right side shows the number of versions and how many entities are of each entity, how many histories of each entity. At the bottom, we have history-related information. On the left, shows the timestamp and the author, while the right side, the commit message. Below, a timeline provides a global overview of the system evolution with additional details about the commit, and by selecting a bubble, we are moved to that exact version of the city. To facilitate moving through time, Metricity provides a control panel. We can increase the speed, decrease it, move forward by a commit, as well as play and pause. For example, let's go at 8 times. And as you can see, things in the city are changing. The visualization is fully customizable inside the setting panel. On the left, there are generic settings of the parts we display, like names pop-up and extra option to color or hide entities based on their name, while the right side shows the artifact setting, which allow a full customization of the city itself. The visualization of entity can be customized by selecting the metrics to use for the base and height of each entity type, and advanced customization can be achieved by changing the minimum size of the base, as well as the value of the multiplier used to give the entity their personalized weight in the city. For example, here we can see that the data file has a 0.1, which divides it by 10 and makes it smaller than the other entities. Below the city, we can choose the type of the city, which also includes not visualizing the city at all. Sorry, the database, not visualizing database. Okay, the user can zoom in and out, as well as rotate the city. Hovering an entity shows its name, and by clicking it, a panel with information appears. At the top, the path of the file with a link to the file on GitHub or GitLab, depending on which repository it is, and there is the type of the change, the version, and the value of the metrics. The timeline highlights the commits in which the entity has been changed. As you can see, they are pink. The point of view of the city can be modified with the mouse click. With a double click, we jump directly to a location, and we can zoom in and see the entities from very close, and it feels like being part of the cities. Here we see an example of yellow arcs, which are used to show when an entity has been relocated in a current commit from the previous version location to the new location. We illustrate how metricity can be used to comprehend the evolution of a system by using GnuCache Android companion app of the GnuCache accounting program as an example. It allows recording transactions on the go and import the data later in the desktop version. The main branch is 1700 commits by 46 contributors. In May 2012, the project repository is created with 83 Java classes, 85 data files, and 240 binaries. The source code is mainly located in the package in the right bottom part of the city, nicely divided into sub-packages. And there are 3 districts of images and several districts of data files. Separately, the module in the top left part of the city has 1 Java class, 4 data files, and several binaries. If we press play, we select a few commits later, the database appears, which is reflected in the commit message. Then we can see that new buildings appear and the size of the entities change. 3 years and 500 commits later, the city looks different. The process is going through major refactoring, which also include the database. At this moment, the entities are moved to a new location. You will see it soon. Now, some table accesses disappear, and soon new ones are added. The database disappears for 1 commit, and then it reappears with new tables and accesses, which are soon removed. This happens because in the source code, the repository of the traces of the interactions with the database are removed and then added again. The revision has 3 tables which are accessed by a few classes. We can see splits, accounts, and transactions, and each has a building in a city named adapter created to interact with it. There is also a database helper which accesses all the tables. Toward the end of the evolution, the classes are located in the same position and new entities have appeared. The system has grown considerably, with some classes reaching considerable size in terms of variables and methods. The tables are noticeably bigger due to the addition of new columns. The communication between the software system and the database is well organized. Only a few classes located in the same package are accessing the tables. Data file districts have been added, complementing systematic database accesses. For example, there are many tall and thin data files in a single district, all of the same sizes. These are used to store the words and sentences of the different languages supported by the application. This is very common in Android application. The history of this repository ends in 2018, with few modifications happening in 2020. I am Susanna Ordigo, and this is the demo of Metricity, visualizing evolving software and data cities. I hope you have enjoyed it. Thank you.
Okay, thank you, Susanna, for the presentation and the demonstration video. Are there any questions from the audience? Just unmute yourself and ask the questions. You can also post the text questions in the chat channel, and I will tell the speaker.
Yeah.
Susanna,
Sorry.
okay, Mitchell,
Yeah, I had just one question on the visualization itself, and sorry if you mentioned it and I missed it, but what do the dimensions of each of the entities, so like the width, height, represent, and how are things structured in the visualization, like with respect to one another? Is it just based off the file structure of the repo, or how is that done?
Are you talking mostly about the entities like the buildings or the districts?
Mostly the buildings in terms of the dimensions, and then both in terms of just how they're placed relative to one another.
Okay, allora, for the buildings, we have code buildings. The base is the number of fields of the class. The height is the number of methods. For data files, we have the base, which is how many properties are for each type of object, and how many entities are in general is the height. Binary don't only have the size. And for the visualization, the city, basically, we pick the biggest value of the base of each entity in the city, and then we compute the layout, which is a resistant layout. The idea is to give a location in the city to each entity, which is reserved for the whole visualization. So if you look at commit 1 or commit 1,000, if the entity is still there, it will be the same location. If the entity is not there anymore, it will be empty, or even if it is not added yet. And then all the districts that you can see, like these ones, which are empty, they are all packages that have been removed. So the location is still reserved, either removed or moved to a new location with a refactoring. And the layout is computed trying to minimize the space. Basically, we try to see, we add one district at a time, and we see if it's better to grow on the right or on the on this side or above. And then we compute it and get the smallest layout possible with the biggest value of all the entities.
Okay, I see. Thank you.
Actually, all the metrics can be changed in the visualization. We have 4 for classes, 4 for data files, and 2 for databases. So very specific cities can be created.
Okay, I think for the first talk, we may kind of out of time. So if we have more time after all 3 talks is done, we can further discuss about this cities visualizing work. Okay, thanks, Susanna, again. And our second talk will be brought by Mitchell. He will talk about their tool in natural language programming. Okay, welcome, Mitchell.
Hi, thanks for having me. Let me share my screen. Are you able to see my slides?
Yes.
Okay, good. Okay, so hello everybody. My name is Mitchell Young, and I'm going to be discussing my paper, the IDE augmented with human learning inspired natural language programming. Whoops. Oh no. Sorry about that. I didn't mean to do a slideshow. Yep, so like I said, I'll be presenting our paper, an IDE augmented with human learning inspired natural language programming, which I worked on. Oh no. Sorry, I apologize. I don't know why it's doing it as a video. I just want to okay, well, maybe I'll just present it like this, since I don't know why it's doing it as a video. But my co-authors are Zifan Nan and Dr. Xiping Shen. All of us are from the North Carolina State University in the United States. And so before getting into the tool itself, first I want to provide some background on what natural language programming is and the motivation behind it. So simply put, natural language programming is the process of using a code synthesizer in order to translate a natural language input query into some working program or code snippet, such as the example shown here. As you can imagine, there's numerous use cases for this type of stuff, pretty much all of which involve some general user who has a task they hope to accomplish, but specifically using some sort of program, but which they may not have the expertise required or even just the time or resources necessary in order to actually create the working program to accomplish that task. So instead, as long as they can just translate that program and the intent behind it into natural language, they can use a natural language programming tool to develop the program automatically. In the case of our tool specifically, we are targeting a subset of this audience, specifically programmers themselves, and more specifically, programmers who are working in domains that feature a very complex and rich API set. So some examples of these types of domains include the AST Matcher domain for the LLVM project or the TensorFlow library for Python, both of which contain over 500 different APIs. So even though a programmer might have experience working with these domains, just due to the sheer amount of APIs and their complexity, it can still be difficult to develop working programs using them, and they can benefit from using a natural language programming tool. So pretty much all past approaches, at least in recent years, have featured a data-driven approach where neural networks and machine learning models are trained on large numbers of labeled training examples in order to translate these natural language input queries into working programs. I think you guys might be familiar with some of these tools, such as I think the most popular one that comes to mind is GitHub's Copilot tool. They've shown a lot of success, but they aren't applicable in all domains, primarily because of the large overhead required in collecting these thousands or potentially millions of labeled training examples required to bring the model to accuracies that are acceptable. So to address this issue, we propose our tool, HiSyn, which stands for the Human Learning Inspired Synthesizer, which compared to the data-driven approaches, which are kind of this black box model where they just copy code snippets from their training examples, HiSyn intends to kind of mimic the same thought processes that a programmer might actually go through when developing a program. So we start with an understanding of the domain and its API documentation, along with the grammar for that domain. And we couple that with a natural language understanding of the user's intent through their input query and combine the two in order to generate the output code expressions. So the main advantage of this tool is that it requires no training data, and it's also much more easily extendable to new domains because it requires no training and just an additional module for new domains. So I don't have time to get into the details of how HiSyn works, but shown here is kind of a high-level diagram of its overall framework design. It features a modular design, which is comprised of three main components. The first of which is the domain knowledge constructor, which is responsible for parsing the API documentation and grammar for each domain. And then there is the front end, which is responsible for parsing the user's natural language input query into an intermediate representation, which is worked on by the third component, the back end, which couples this and the information from the domain knowledge constructor in order to synthesize the final output code expressions. We have evaluated HiSyn and its accuracies on the three different domains shown here. And what we have found is that it achieves accuracies comparable to the leading data-driven models using the available training data for the text editing and ATIS domains. And it actually has much better accuracies for the AST Matcher domain, which compared to the leading rule-driven approach. And as mentioned, HiSyn is intended for programmers. So we have decided to integrate the tool with the Visual Studio Code IDE, which is one of the most popular code editors available. And it also features a very rich API for building the extensions and a lot of community support. So maintaining the extension and adding features to it over time should be fairly easy. The main features of the tool are obviously the natural language programming made available through HiSyn itself, as well as additional tools and features for working with the domains currently supported by HiSyn. So this includes code snippets for typical programs you might create using those domains, as well as additional tools for the AST Matcher domain. So yep, that concludes kind of this introductory presentation. And if there are any questions, I suppose you could ask them right now before I get into the demo. Otherwise, I'll go ahead and start showing off some of the features of the extension. Okay, then I'll go ahead and just give a demonstration of the tool here that I have open. Okay, so I don't know how familiar everybody is with Visual Studio Code, but this is what its interface looks like. On the left side is kind of where you would work with various extensions, look at your files and stuff. So the Hyson extension can be found on this left side panel through this icon shown here, the brain. And if you click on it, in this panel here is kind of the main extension interface through which you can execute the various commands it makes available or just view information related to it. So it's a very simple layout and should be very intuitive to work with. So by default, Hyson works based off making APIs to a web server we have set up with a Hyson engine. However, currently the server is actually down for maintenance. So thankfully, it is also equipped to be set up using a local installation of Hyson that you might have. And for the demo today, that's what I'm going to be focusing on. So, and the local version can be configured by going to the settings and simply supplying a path to where that local installation is on your computer. So in the case, the Hyson version I have installed on my computer supports the following 3 domains, which is the same as the engine on the web server. And currently I have no custom domains added to it. Okay, so the first thing I'm going to demonstrate is building a Clang tool for the AST-Matcher domain, which is one of the supported domains here, using some of the code snippets that we have in the extension and using the natural language programming feature of the extension. So first I can get this program started by using the code snippet we provide for building these Clang tools, which is a very common use case for the AST-Matcher domain, building tools to be used with the Clang compiler of the LLVM project. So I can insert this template by either clicking on it in the interface here or by typing out its name in the code editor and selecting it from there. And this is the inserted template. And right here is where I can edit the tool itself and what specific code I want it to match using the AST-Matcher domain. So currently it's just matching any for statements in the submitted source code. So I can edit this to be something a little bit more complex. And in this case, in the interest of time, I'm going to use this preset example I have here. So instead of just finding all 4 statements, I'm going to find just those 4 statements who are initialized with a variable that is set to the integer 0. So we can edit this by using the natural language programming through Hyson. And we can do this by either pressing the play button shown in the extension interface here, or directly through the Visual Studio Code command palette where all of the available commands can be found. In this case, this one is called run Hyson. And to use the natural language programming, you'll just submit the domain you want to work with, as well as your input query through a series of input boxes. So here I'll select the domain, and I submit my query. And then a pop-up will show here saying it's been submitted to Hyson and working on it. And then it'll output all the different or valid code expressions, and you can select from them shown here. So there's only one valid input in this case, which I can select, and that is inserted directly into the code editor. So there should be minimal effort for the programmer themselves in order to leverage this feature and insert it into the program. So I could save that now and then use some of the additional features in order to build this into my local LLVM project. First by using this build Clang tool. Again, using a series of input boxes, giving it a name, and submitting it, and that will be compiled into my local LLVM project. And once it's finished, I should be able to actually run it against any chosen source code in order to match those specific types of for statements. And it may take a while to build, so yep, there we go. So it finished building, and now I can test it on some example code. So here is a C++ file with several for loops in it, some of which have a variable initialized to 0. So I can now right click on this and use the run clang tool command, select my newly created tool, and it will output in the code expression or the terminal here all the code which match those for loops. Yep, so I think I'm out of time, so that concludes my demo. I guess I'll quickly answer any questions people might have regarding the tool.
Okay, thank you, Metro. Are there any questions from the audience? Oh, hi, Metro. Actually, I have a small question. I see that you pass the natural language descriptions and for the following programming generation. I just wonder if the natural language description is not written carefully following the grammar rules. Your tool still can generate the programming?
Yeah, so as mentioned, it's ideally the tool is intended for programmers that do have some experience with these domains. So it will work more, the accuracies will be improved. The output code expressions will be better if they follow kind of a language that follows the API documentation, uses similar terms or the API names themselves. So yeah, like in the example I showed, I use a specific language that kind of follows the terms used in the AST master domain. So there is kind of a learning curve with using the correct language for the given domain in order to generate the correct examples. It's not perfect, I guess I'll say. If you're not using the right language, there may be some improper code expressions that it generates. But I think the general idea is for it to generate, give you an idea of the correct APIs that you're looking for, given your intent.
Okay. Thank you. Are there any questions? Okay, I think we can go ahead with the third talk. And when all the talks are delivered, we may have more time to discuss. Okay, thank you, Metro, again for your presentation. And our third presenter is Pop. He will talk about their work about marrying and blasting chatbots. Welcome, Pop.
Hi there, good morning. In my case, I have record a small talk and with a demo inside. I don't know if you can share the sound of my screen. I'm going to play it. Yeah. You say me if you hear.
Yeah. Oh, sorry. I'm afraid I cannot hear the voice.
I think that the voice is there. I think that the voice is mute. No. I must change something in the setting.
The video.
But you can hear or no?
I can hear your voice, but I cannot hear the voice from the video. You are playing a video, right?
Okay. And you cannot share it. I think that I can see that in the screen the voice has the icon of mute in the panel near to my name, Pablo Cañizares. On the right, you can see a mute.
It does not matter. It does not matter. I can hear your voice, but not the video. Are you playing a video, right?
Yeah, I'm playing the video, but it has no if I'm not able to share my sound, I have well, an emergency plan. I have the slices. If you want, I can change to the slices. But well,
You might need to choose the right microphone source on your computer, I think.
if you want, I can share my slices and I talk about the slices.
That's
This was not my first plan, but well, you know. And second. What? Second. Share screen. Well, now, good morning, everybody. My pre-record video is over, and next I'm going to do some freestyle at this moment. So I'm going to present my Asimov, that is a platform for measuring and clustering chatbots. I work together with Jose María López Morales, Sara Pérez Soler, Esther Guerra, Juan de Lara, within the MISO Research Group of the Universidad Autónoma de Madrid. Chatbots are a set of conversational software which offer us a set of NLP interface that focus on providing software interfaces and some services, and are focused on giving different services related. For example, with leisure, you can find different chatbots related with the shopping, to book some flight, to book some hotels, and also it provides some customer services. And for example, it provides you some agents that allows you to answer some problems or some answers that you want to receive. You have some problems. And in the case, for example, of the bank, you can ask to these agents in order to have some associated responses. Also, you can find different services, for example, for the weather, then you can answer these chatbots in order to have a specific information related with that. This is an example of a chatbot support, and you can provide to the chatbot some question in natural language. This chatbot processes this sentence and try to provide you the required information. No? These chatbots can be deployed in many channels. One of the main objectives of these channels chatbots is to provide information, and you can find different chatbots, for example, in social network. One example or representative sample of that is the Telegram chatbots, where you can establish a conversation with a chatbot in order to, to buy some cinema tickets, etc., or to try to have support with a specific shop. And also it can be deployed in websites and also on smart speakers in the case of, for example, Amazon Alexa. Then many tools have emerged to cover these necessities of building chatbots. You can find one of the most famous proposal, that is the Google Dialogflow. You can also find Amazon Lex, and also IBM Watson, Microsoft Bot Framework, Rasa, etc. But well, you know that chatbots are a software system, so maintaining the quality of software is essential. No, also it is applied to the chatbot success. But unfortunately, in the literature, we have not found any proposals that lack quality assurance mechanisms, like for example, metrics that can be used at design time. Several times you can find different proposals focused on dynamic testing, but it requires to have the system deployed in a real environment, and in the design time, sometimes you don't have this kind of environment. So metrics are necessary, and also there's a lack of mechanisms for comparing, also clustering and classifying chatbots along different design features and also conversation topics related with the words and the topics used by the chatbots during the established conversation. For this, we propose Asimov, that is a web platform enabling different features. One of them is the chatbot measurement using a suite of 20 metrics. We have created 20 metrics and divided in different groups. Some of them related with general purpose metrics, related with the complexity of the chatbot. It measures also the reading time or the time when needs the chatbot to play this the provided output to the user. Also, for example, measure the sentiment of the chatbot, and well, we have several metrics, and also allow the chatbot comparison along different set of metrics. For example, we can group or identify group of chatbots that are complex or provide a larger responses, etc. And also, well, it's a web platform that allows to searching chatbots using some characteristics associated to different metrics. No, also it provides a core for analyzing and providing statistics of all chatbots in the repository. We will later see that in the demo. You can select different chatbots, also select different metrics and see statistics about that. And also it has a feature related with clustering chatbots related with this metric that they have set, and also by conversational topics. And for that, the chatbots, the Asimov analyze the response given by the chatbots, and well, using NLP techniques, try to group by different topics, and also provide a set of the most important words that are used in each cluster. No? For example, if there are in your repository several chatbots that are related with hotels, this cluster provides the most important words. For example, booking, and well, another set of words that will be appear in the demo. And also, well, Asimov support multiple chatbot technologies. It is built inside of on the top of a neutral chatbot design called as Conga. For this reason, Asimov support different types and platform of chatbots. For example, we support Dialogflow, Rasa, and Pandora Bot is coming soon. And for this, we have developed different importers, so that we have a neutral language, as I said, called Conga, that has an extended meta model whose main feature has been extracted from 15 different platforms. So in this case, I think that I'm going to in this case, play the video demo if you want. So this is not the video demo, but well, I have another. Well, let me stop it because I also had the record audio, but now do freestyle again. One of I am going to provide you several use cases in the demo. The first one is the sign up. When this is the Asimov platform. Well, in this case, the login. You must click on the login, provide your username, your associated password, and when clicking the login button, well, you are inside on the platform. This is very easy. Associate your username. The login, I think that the name are changed. Is the sign up to register into the platform. You can provide the username, write the username, select it whatever you want, selecting your password, repeat the password, and well, also to sign up in the platform. If the passwords are okay, it provides you access to the platform. Well, the next one is uploading a boat. Asimov allows you to upload a boat. Clicking on the boat selecting from your system the bot that you want to upload to the platform. You can change the name of the chatbot. Also select the visibility. It can be public, or on the contrary, it can be private, and select the original platform when the chatbot has been designed. Also, it supports different version names, so you can upload different versions of the chatbot for later compare them, trying to find commonalities between them on the different aspect that has changed during the time. No? You can upload the bot, and well, once the bot has been uploaded, you can measure this chatbot. No? In this case, you can click to the left menu, metrics, also measure chatbots. Then you can find the chatbot by typing the name and also selecting it from the repository if it is uploaded and selected. Later, you can select the different set of metrics, bot, entity, flows, and intents. Measure the selected metrics, and then you can see flow metrics of the different chatbots, entity metrics. And well, these results are shown in different tables. And also we display the result in Instagram, comparing the chatbot, this single chatbot with all the repository. And you can find, well, you can analyze it using different metrics. Then you can compare chatbots. The previous one, you can able to compare one chatbot with the whole repository. In this case, we are going to compare different chatbots, one by one. You can select from 2 to the whole repository. In this case, it appears the whole repository in your screen. You can select the bots that you want to compare. Use the different metrics that you want to use. You can select a subset of the whole suite. And then Asimov shows you in a set of graphs all of these metrics that we have selected. And also you can compare this subset of chatbots with the whole repository, again, by using these graphs and an histogram. You can see these results. Also, you can search at the chatbot by using queries. In the metrics section, you can select the metrics, search chatbots, and selecting the different queries given a range of values of the different metrics. And you send the query, and it recovers from the repository all the chatbots that fulfills this constraint. No, well, you can click it inside of them to show the specific value of the query metrics. Then we provide also functionality for clustering chatbots. In this case, the first use case is just clustering by using, as I said, the metrics clustering. And then you can configure the parameters of the clustering. For example, you can choose the number of clusters and how many components are used to display the result, how many dimensions. Select the metric used to cluster. In this case, we are going to select all. And what chatbot do you want to include in the clustering process? In this case, all of chatbots. Create clusters. When the greater is the number of chatbots, the greater is the time needed to process the whole process. And well, it displays all the chatbots. You can see the different clusters of the chatbots, different components. And then at the right part, you can see the characteristic of each chatbot, of each cluster, related with the metrics. Also, you can see principal component analysis, the loaded metric on displaying variants. And then I think the last use case is the semantic clustering. It allows you to group the chatbots.
Excuse me, Pop. I'm afraid you have run out of time. So can you quickly just go ahead with your demonstration? Then we can have time for one quick question.
Oh, okay. Yeah, I think that this is the last use case, but well, if you want, I can stop it. Here is we conduct some clustering process related with the conversational topics of the chatbot. And well, here you can see the different cluster created by the repository. And well, if you want, I stop.
Okay,
Thank you very much.
Thank you, Pope. Are there any questions? Yes, we can have time for one quick question, I think. Actually, I have a small question. I'm not quite sure what is the input for your tool. Are the source code for the chatbot or the design
Yes,
materials for chatbot?
Yeah, the input of the platform is a chatbot inside. Imagine you have a chatbot deployed in Dialogflow. You can export it to your disk on the Dialogflow format, but you can upload it in a Dialogflow format, and it converts to the neutral languages that provide Asimov, and then it conduct all the process. So you need to. It supports Dialogflow and also Rasa formats. In the future, we want to include several formats more, several platforms such as Pandora Bots, Watson, etc. But now, for the moment, you have to these formats, and well, the input is the chatbot.
Okay, thank you. Okay, let's thank all the speakers again. And if you have more time, I think you can still get in touch with the speakers on the Socialize the channel. And this is the end of this session. I hope you can enjoy the rest of the conference. Bye. Thank you.
Thank you.